here with us. Okay, so these are the answers that I had promised you last time. These are the questions I gave you for homework. So I want you to take screenshots of these. We don't have time, unfortunately, this lesson to discuss this. So I'm going to put up the full solutions. You can go and mark your work, compare the answers that I've got to the answers that you had. And if there are any questions, we can talk about it on Thursday at the beginning of that lesson. Okay, so 5A, here is our solution in green. So there's 5A. You can take a screenshot of that. There's the answer to question B in blue. So that's 5B. So please take a screenshot of that. I hope I didn't make any mistakes. So yeah, everybody take a screenshot of that. All right. And then here is the answers to questions 6A. So again, this had to be solved simultaneously, so it's a little bit long. There's the first part. And then I'll move the screen down so you can take another screenshot or come back and watch the beginning of the video again. I'm going to move it down now. Okay, so that was the beginning part of 6A. And then there's the end bit. So there's our two solutions for R. And as we had two solutions for R, there were also two solutions for A as well. Okay, so that's in blue. Okay, and that means we had two different sequences here. The answers have been written in green. So term 1, term 2, term 3, and then again term 1, term 2, term 3. Okay, so I know there's quite a lot going on there. So I hope you guys are all screenshotting this. Okay, and I think that was it. Oh, yes. Okay, so that was the answer to question number 6. All right, so I'm just going to go back over question number 6 again. There's the top bit, solving simultaneously, going down, working out our solutions for R, then our solutions for A, and then our two different sequences. Okay, so there we go. So you can go and mark your work, and then you can let me know next time that I see you how that went. Okay, all right. So today we're moving on. We're talking about Euclidean geometry. That is going to be our next course. I know a lot of you, once you had finished with sequences and series at school, you probably move on to functions and inverses. Functions and inverses, well, not functions, but inverses, which is the only new thing that you get taught in matric as far as functions are concerned. It's a very, very small part of your final year paper and your trials paper. So you're looking at anywhere between 5 and 8 marks. It's a very, very small section, a lot of work for a very, very small section. So we're not going to be doing a course on inverses at the moment, but it is very important that you go back and revise your functions. So you need to make sure that you know everything about the parabola, the hyperbola, the exponential function from grade 11, because that's all going to be tested. All of those are going to be tested in matric as well. We will do revision with that with you at some stage in the year, but that's actually grade 11 work that we're theoretically supposed to be able to do, but can cause problems. All right, so we're moving on to Euclidean geometry. Some of you may be doing this at school, you may not be, but don't worry. Our first lesson or so is just going to be a revision of what it is that we are already supposed to know from grade 11. What I suggest you do is try and take as many screenshots of the information as you possibly can. I've made these summaries. I think it sort of explains everything very nicely. And I'm just going to go through this with you and then do some examples. Okay, so things that we're supposed to know. And again, I'm going to give you a little bit of homework. Okay, Zanele, I see you've got your hand up. Do you want to ask something quickly before we get started? You're welcome to unmute, Zanele, or put your question in the chat.
Sorry, Zanele, I have unmuted you on my side. There we go. You can answer. Daniela, you should be able to communicate now. You can talk on your side. Okay. It could be that Zanelle's audio also.
Okay, well, in that case, I'm gonna move on, and if Zanele has still got a problem, then she can communicate with us over the chat. Okay, so the first thing that we learned about when we were in grade 11, or at least I know this is the first thing I taught my grade 11s, is we learned about the chord theorems. Okay, the chord theorems. And the first one that we're going to talk about is line from center to midpoint of chord. That should ring a bell right now. Okay, so when we're using the reason line from center to midpoint of chord, we have been told that M is the midpoint of AB. So in other words, that AM equals MB. So in other words, we know that that line segment and that line segment there are equal. This allows us to conclude that OM is perpendicular to AB. And another way of saying it is that OMB is 90. So if you're proving the angle at M is 90, the reason is line from center to midpoint of chord. The other chord theorem that is important for us is this one, line from center perpendicular to chord. So here we have been given the right angle. The diagram comes with the right angle, or they tell us at M the angle is 90. So this information is given to us. This allows us to conclude that AM equals MB. So if we're concluding that AM equals MB, then it means that we are using line from center perpendicular to chord. So people often get very confused with these. So I'm going to run through 2 examples and then we are going to move on. All right, so please take screenshots every step of the way so that you're able to get all of this information. All right, so the first question that we are going to have a look at is this one over here, question number B on the left-hand side. All right, and the first thing that we must do with every geometry question is make sure that we read the information. All right, so they tell us that O is the center of the circle. That's fine. And they tell us that EO is 3 units. That's this bit over here. They tell us that OF is 2 units. That's this bit over here. And the other thing that they tell us is that we have got a 90-degree corner. So it comes with the 90-degree corner. That means the triangle OEF is a right angle triangle. They want us to calculate the length of DE. So because we've been given this 90-degree corner at E, it means that DE equals EF. So if we can work out the length of EF, we've got the length of DE. All right, so how are we going to work out the length of EF? It is one side of a right angle triangle. So what do we use when we want to calculate the missing side of a right angle triangle and we've been given 2 other sides? What reason do we use? That's it. We use Pythagoras, quite right. So in other words, we are going to use theorem of Pythagoras to work out EF. Then we're going to say that EF is equal to DE, line from center perpendicular to chord, and that's how we're going to calculate the length of DE. So we will start off by stating that FE squared plus EO squared is going to be equal to FO squared. And we're going to use Pythagoras as our reason. Now we're going to go and substitute in. So FE we don't know. That's what we're trying to calculate because FE equals DE. EO is the square root of 3. And FO is 2. Making FE the subject of the formula, we're going to take this term over here over to the other side. So that's going to be 4 minus 3. So that means that FE squared is 1, and thus FE is going to be equal to 1 or 1 unit. Now we can conclude that FE equals DE. Remember, we've been given the right angle over here, so we say line from center perpendicular to chord. Therefore, DE also equals 1. No, you cannot ever assume Nkoniza, I hope I'm saying your name correctly. Okay, you cannot assume that something is perpendicular. If they tell you it's perpendicular, then it's fine, like they have in this question. But you cannot just assume that there's a 90-degree corner. Okay, so either they'll tell you or it's something that you need to prove before continuing on with the question. Okay, so that is an example of how we would use line from center perpendicular to chord. Everybody good with that? Oh, is it making sense? Are we happy? Thumbs up. Take screenshots.
Well done, guys.
All right, very nice. All right, good, everybody. Okay, so now I'm going to do an example with you, right, on how we would use line from center to midpoint of chord, and that's where this particular example comes in over here. Okay, so I'm just going to move over there, and let's just get ourselves a little bit of space. Okay, there we go. All right, so hopefully that's big enough and everybody can see it. I can make it a little bit bigger if you need me to. There we go. We just still want everything in the middle of the screen. Okay, so here they give us AB is a chord. So AB is the chord of a circle. So there's AB over there, right? And they've told us that AD equals DB, right? So if they tell us that AD equals DB, what does that mean for the angle at D? What does it mean for the angle at D? Yes, it's equal to 90. Yes, quite right. It's equal to 90. Okay. Yolanda, maybe you can help. Nkoneza. She's asked a long question there. All right, lovely. So it's equal to 90. All right, good stuff. All right. So if we say that this angle over here is equal to 90, it means that DBO is a right angle triangle. It also means that DOA is a right angle triangle. So if AD is 12, that means that DB is also 12. Okay. The other bit of information that's perhaps not so obvious here, and what I'm going to do is I'm going to rub out the green line and leave the 12, is I want to point out that there are lines here that are going to be equal to one another because they are radii. So OB is the same length as OE, sorry, badly drawn by me, is the same length as OA because they are all radii. Okay, so if I know how long OE is, I also know how long OA and OB are. So they tell us that OE bisects AB. We've all decided we know what this means. It means that at D, okay, so D1, 2, 3, 4, whatever it was, it's equal to 90. There's a 90-degree corner over here. The first thing that they ask us to do is determine the radius OB in terms of X. So when they ask us to write something in terms of X, it means that we need to write an expression, right, for our answer. So I'm going to show you what I mean by that as follows. All right, I can see that from O to D, it's X units long, and from D to E, it is 8 units long. They've told us this over here. So that means that the length of EO is X plus 8. So EO is equal to X plus 8. There is its length in terms of X. But EO is equal to BO because they are radii. So that means that BO or OB is also equal to x plus 8. All right. The next thing that they want us to do is they want us to work out the length of OB. Katlego, I'll take your question when I'm finished. Okay, I'm just going to finish this example and then you can certainly ask. Okay, so just hang tight. Hence, calculate the length of the radius OB. So now, Iconesa, this is, I think, what you were trying to ask me, all right? I cannot apply the theorem of Pythagoras to a triangle that I don't know for sure is right-angled. So if I need to work with the theorem of Pythagoras to solve something, I may sometimes, in this specific situation, is the example, I need to prove the triangle is right-angled first, because I cannot apply the theorem of Pythagoras to a triangle that's not right-angled. So I first need to say that the angle at BDO is equal to 90. Okay, my reason for that, line from center to midpoint of chord. Okay, because I have been given the midpoints. Now I have firmly established that triangle ODB is right angled. Now I can do the theorem of Pythagoras. So I will say that OD squared plus DB squared is equal to OB squared. Okay, because of the theorem of Pythagoras. Now I can go ahead and go and substitute. I know that OD is X. I know that DB is 12. Okay, I just need to square it. And OB is going to be the same as OE, so it's going to be X plus 8, and that also needs to be squared as well. So now I'm going to expand all my brackets. This is going to give me x squared plus 144 equals, now I'm squaring my binomial, so that gives me x squared plus 16x plus 64 when I square my binomial. If I take my x squared term over to the other side, so in other words, if I move this term over to the left with that one, those two terms highlighted in yellow are going to cancel one another out. So what I have got on the right-hand side is 16x. If I say 144 minus 64, that's going to leave me with 80. Divide both sides by 16, and that means that x is equal to 5. Remember, they wanted the length of BO. All right, so it was x plus 8. So that gives me 5 plus 8. So therefore, BO is going to be equal to 13. Okay, now, are there any questions? Any questions on this? You're welcome to put your hand up, and then Yolanda will unmute you. Okay, Amina?
Hi, ma'am. Okay, so a lot of times I get confused when it comes to, like, you see, we have x squared plus 114, which equals to x squared plus 10 squared plus 64.
Yes.
So I always get confused. Do we take the 144, not 114? Do we take the 144 to the right, or do we take the 64 to the left?
Okay, so what you want to do here is you want your x terms one side, Amina, and you want your number terms the other side. So it doesn't matter which side you choose to collect them on. So if I wanted, what I could do is this. So I could take this 16x over to that side, but then it would become negative 16x. And if I take this plus 144 over to this side, it would be 64 minus 144, which would give me negative 80. Then if I divide both sides by negative 16, you're going to see I'm going to end up with the same answer.
Oh, Oh, okay.
Okay, all right. So it doesn't matter which side you choose to collect your x's on or your numbers on. If you are solving an equation that's linear, x terms one side, number terms the other side. Okay.
Thank you, ma'am.
All right, no problem. Were there any other questions? No one else has got their hand up. Okay, so remember to take screenshots as we go along. Remember, our lessons are recorded, so you can go and watch this again. No, Ethan, you will not be penalized for not putting the word units next to your answer. Obviously, nice to do that, but they won't penalize you if you don't do it. Okay, all right, let's go back to the next bit of information. Let's just make this a little bit bigger as well. Okay, so again, I want you to take screenshots here wherever possible. There we go, that's in the center of the screen. So the next thing that we are going to talk about are our, they call them formally, our segment angle theorems. But what this really means is that these are the angles on the inside of circles. So these are the angles on the inside of circles. Okay, and let's just have a look at the different types. All right, so if we have a look at number 1, we have got the good old bow tie. So I'm going to join those lines together. There is my bow tie, very important. A, B, C, and D are all on the circle. That's what makes the bow tie. So if I want to conclude that angle A equals angle D, or that angle B equals angle C, my reason here is angles in the same segment. Okay. The second one. Okay, the angle at the center. So this angle over here, all right, is twice the angle at the circumference. Okay, so BO and CO subtend this angle at the center, and they also subtend A at the circumference. All right, so I would say that BOC is twice as big as A. Angle at center is twice angle at circumference. Okay, there's a question. Let's have a look. Ma'am, what is a segment? Okay, so a segment is a piece of a circle. All right, so in other words, if I get rid of my bow tie over here, okay, a chord cuts an angle into segments. So chord BD cuts the circle into these segments. So that the smaller segment I'm highlighting in yellow, that's a segment. Okay, and the other segment over here would be what's left. So that's the other segment. Okay, so that would be this bit over here. All right, that's what a segment is. Okay. All right, so we're staying with angle at center is twice angle at circumference, because the first one in number 2, this shape over here, let's just get rid of this. This is the arrowhead. Okay, you can see it's like the head of an arrow. Okay, so we can still have angle at center is twice angle at circumference, but the shape of ABOC changes. All right, so now I've brought point A further down, closer to C, and that means that line BA is crossing over line OC, but I've still got the angle at the center is twice the angle at the circumference. It's very important that we don't get confused between number 1, okay, and number 3. Remember here, all 4 points are on the circle. Here, this point over there, the angle at the center is not on the circle, it's at the center. Only A and B and C are on the circle. Okay, so angle at center is twice angle at circumference. And then the last shape, I'm going to take your question now, Ria Betswe, is this one over here. If you can imagine what I have done is I've got hold of point B and I've got hold of point C and I've moved them further up. Okay, so I've moved B and C further up. So now it's not going to be arrow shaped anymore. It's going to be diamond shaped. Okay, again, the angle at the center is this angle over here, that big reflex angle, and it's twice the size of angle A. So that is also angle at center is twice angle at circumference. Okay, I'm going to stop and take questions. What is the angle at the circumference? So Sihawu, that is the angle that is at the circle. Okay, so in the case of all of these, in 2 and 3 and 4, A is the angle at the circumference, the angle at the circle. Okay, so this is the angle at the circumference. This is the angle at the circumference. This is the angle at the circumference. Remember, the circumference is the circle. Okay.
Rabetu has a question. Rabetu, go ahead.
Hi, ma'am. I just wanted to ask, is the difference between 1 and 3 the fact that 3 doesn't really, like, it doesn't touch the same segment, or what's the difference between, because they're both
No.
like the whole thing?
They look very similar, but the biggest difference between 1 and 3 is that in number 1, A, B, C, and D are all on the circle. They're all at the circumference. In 3, okay, there is a fourth point at O, but it's not on the circle. Okay, it's in the center. Okay, so these are two actually completely different things. Angles in the same segment is not the same thing as angle at center is twice angle at circumference. But because it makes that sort of bow tie shape, we sometimes get confused. Okay. All right, and then Amina, I think you also had a question.
Yeah, I've given the opportunity to Tehofato. Tehofato, do you want to unmute on your side? Yeah.
Ma'am, I still don't understand the third thingy, the
Which one, Tehofato?
third one, ma'am.
The third one, this one over here.
Yes.
Okay, all right. So what I've done here, Tehofato, is I have taken the diagram from number 2 and I have just changed it a little bit. Can you see the diagram number 2 and diagram number 3 are quite similar? What I've done is I've taken this point over here, A, and I've moved it further down the circle. So if I could hold that over there and I could drop it over here, okay, now I've got a situation, oh, sorry, that doesn't help you. I've now got a situation where instead of AB is now over here, because I've moved A down on the right-hand side, I've now got BA over there. Okay, if you have a look here, there is OB, there is OB. Okay, here is OC, there is OC. Okay, and this line over here that joined, let's just make this a different color. Let's go with purple. Hopefully that's different enough. This line over here that joined A to C is still this line over here that joins A to C. Can you see that now?
Yes, ma'am, but how is, I get the thing, it says
So the angle at the center
center is 2 times angle at the circumference. So I am failing to see that.
Okay, I don't, what do you not see?
Like, for instance, ma'am, the second diagram, right? It says angle at the center is equal to 2 times the angle at the circumference. So it means
Yes.
that at the angle, like you just show us the angle, like, oh, yeah, that angle is 2 times the angle.
As big as A, absolutely. So in other words, if this angle over here was 120 degrees. This angle over here would be 60.
Yes, ma'am.
Okay.
So to see that on the third diagram, like I can't see how does the theorem apply to the third diagram.
Okay. I think what I'm going to have to do is just let me try and do one of the other examples with you. And let's see if instead of us working with letters, if we're actually working with numbers, if this makes just a little bit more sense to you. Okay, so let's go and do a look at an example, and we're going to put all of this into practice, and hopefully you're going to be able to see a little bit better what it is that I'm talking about. Okay. So I'm not going to worry.
Yeah.
I beg your pardon, Yolanda?
No, I'm saying that this will definitely help because she will do more examples on this and she will understand better.
Yeah, absolutely. All right. And then just the last one that I want to go over here before we do this question is angle in a semicircle. Okay, so angle in a semicircle, we have that when we have been given that a line is a diameter. So in this case, we have been given that this line over here is a diameter. All right, that means that it subtends or creates or supports a right angle at the circumference. So in other words, this angle over here at A is 90. BAC is 90. Okay, so angle at center, angle in a semicircle, all right, means that the angle at the circle or at the circumference is equal to 90 degrees. Okay, so let's have a look, all right, at this question over here. All right, let's work with some numbers. Now, there's a little bit more going on here with this particular question, all right? The other thing that's going to make it a little bit more challenging as well is the fact that we have a cyclic quad, all right? But let's see if we can get through these answers, even though they've told us that it is a cyclic quad. All right, so first of all, ABCD is a cyclic quad. So in other words, over here, ABCD, there's ABCD. Okay. They have told us that chord BC is parallel to diameter AOD. So now I'm going to rub that off. And the two lines that they've told me are parallel is going to be this one over here and that one over there. There are my parallel lines. BD is joined, fine. Determine the size of angle A, angle B, and angle C. All right, so let's go back and have a look here. When they tell us that a quadrilateral is a cyclic quad, what does that mean? What does a four-sided shape have to have in order to be a cyclic quad? Can you guys remember from grade 11? Yes, and Kuneza, perfect. You've already got the first answer. Lovely. Ria Betswe, did you want to answer? You're welcome to unmute. Well, Yolanda will unmute you.
I don't see Riabetta's hand anymore. So.
Oh, okay. All right. No, that's fine.
Riabetta says it's okay. Yeah.
That's right. Florby says the circle must touch. I've got this silly thing in the way here. The circle must touch. Why is this thing here? Yes, the quad must touch all sides of the circle. Quite right. Opposite angles must equal to 180. Absolutely. They've got to add up to 180. So I don't know if the rest of you saw Florby was quick off the mark there and worked out the size of A, because this angle over here at A is the exterior angle of the cyclic quad, because side BC has been extended. So that was really good. So we would say here that A is equal to 70 degrees because of the exterior angle of a cyclic quad. Well done. Okay, so now that means that we've got that angle over there. Then they want us to work out angles B and C as well. So if we have a look at B next, they have told us that AOD is a diameter. So if AOD is a diameter, what does that mean about angle B2? What is it equal to? Angle B2 has to be equal to 90. It certainly does. So now again, I need to establish that first. I've got to say that angle B2 is equal to 90. Reason, angle in a semicircle. Okay, and now that I've done that, I'm allowed to say that angle B is equal to 20 because of the angles of a triangle, okay, that add up to 180 degrees. That's it. Well done. Perfect. And now I can work out the size of angle C. All right, so angle C is going to be next. Because I have got parallel lines, I can see here, so I'm just going to point out the parallel lines to you again. Here they are. These lines are parallel over there. So the minute I have lines that are parallel, I start thinking about corresponding co-interior or alternate angles. And in fact, here, what I have are alternate angles. So angle B1 is equal to angle B. So it would be equal to 20 because of alternate angles. That is because BE is parallel to AD. Remember, I have to name the parallel sides. Okay, why is it important for me to know how big B1 is? Again, I'm going to delete here. All right, and I'm going to show you the triangle. Okay, so here I have a triangle with an extended side. Okay, so that means that if I add B1 and C together, I'm going to get angle A. All right, exterior angle of triangle. So in other words, angle A on the outside is the sum of B1 and C because of exterior angle of triangle. So I know that A is 70. I've already proved that. I know that B1 is 20, and that allows me to work out C. So C has to be equal to 50 in this case. All right, now I can see there's how you got B2. Okay, angle, so Ola, it was because AOD is a diameter. So the diameter subtends a right angle at the circumference. So B2 is equal to 90 because of angle in a semicircle. Okay, so
Yeah,
B.
I see. Sorry, yes.
Yes.
No, I'm just saying Riabet and Katleho has some questions also.
Okay, that's fine. So you can unmute them.
Ma'am, I just wanted to ask, since we already knew that B2 is 90 degrees, right, from the angle in a semicircle, wouldn't we also got like the B, the lowercase b using interior angles of a triangle?
Absolutely. 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 That's exactly it. That's what I was trying to do. You're quite right. That's exactly what I was trying to do over here. Okay, 100%. Does that make sense to you?
Yes, ma'am, because I thought like you
Oh.
got the B using the alternative angles. So I was kind of like,
No,
I didn't see it at first,
no.
but I saw it now.
Yeah, no, I didn't. Okay, and then there's a question again about the alternate angles. So let me rub this off and I'll show you again the alternate angles. So first thing that I need to do is identify the parallel lines. So I'll tell you what, let me make this a little bit smaller and let's do that. So here are your parallel lines. There's the one parallel line. There's the other parallel line. And here is this line joining those two. Okay, so this angle over here and this angle over here are alternate angles. They are equal to one another. All right, that's why I've said this over here, that B1 equals lowercase b because of alternate angles.
Okay, we have Amina also on the question.
All right, Amina.
Sorry, ma'am, I just wanted to know, to get 20 for B, we took 180 minus the 70, and then also, I mean, minus the 90 and then minus the 70, right?
Correct.
Okay.
Correct. Perfect. Okay, 100%. And then there was just one more question as well, and I'll just go back over that again. And this again is something that's really, really important at matric level, okay, is the exterior angle of a triangle. It's something that is often overlooked. So here is your triangle. Because side BC is extended to E, A is the exterior angle of triangle BCD. So I'm going to say that again. Because BC is extended to E, angle A is the exterior angle of triangle BCD. So remember, the exterior angle of the triangle is equal to the sum of the two opposite interior angles. So this is your exterior angle, and it's equal to the sum of the two opposite interior angles. Okay, so we can see here there is lots of stuff from grade 8 that we need to know for now. We will do sigma notation later in the term. I haven't got a date for that yet, but it is something that we're going to do as revision before you guys start writing control tests. Okay, do you know when? Yes.
I just wanted to know, what if you used ma'am, I can't remember the reasoning, but like when you say
what cut level?
The U, ma'am, I get sorry, ma'am. The fun thing, ma'am. You know when you write fun.
Yes.
I know that it's corresponding angles and then it's alternate angles. I can't remember the other one.
Okay, that's
angles,
co-interior angles. That's quite right. So I'm going to show you. There is a U shape. Sorry, that's supposed to be a straight line. There is a U shape. Okay, so in other words, what we could say here is that if we add angle B1 to angle B2, plus we add 70, we would end up with 180 degrees because of co-interior angles. So that over there plus this one over here adds up to 180. That's co-interior. Okay. All right, no problem. Can I move on? Are we okay?
I think because of the time, we can move on. I still see 2 hands, but I think due to practice and rewatching, you guys can get it. And maybe those questions can get answered also on this example that teacher Leigh is going to show us now.
Okay, so we're going to do this example over here. This is a slightly more complicated, well, not that much more complicated, but a slightly more complicated diagram, and it also brings in angles in the same segment, which we were talking about earlier. So let's just have a look at this and let's see how we feel after this one. Again, read your information first. They've told us that O is the center of the circle. They've told us that AB is a diameter. So straight away, when we see these clues, we need to start trying to link these things to stuff that we already know. So when we see the center of the circle, we say to ourselves, maybe we've got angle at center equals 2 times angle at circumference. That's one of the things that we start thinking about. If we see the word diameter, then we start thinking about angle in a semicircle. Okay, so it's important to read the clues and link them to something that you already know. The other bit of information we've been given is that AOC is 104. So AOC, so that's this angle over here, is 104 degrees. Let's put that in. And DAB, so in other words, angle A2 is equal to 32 degrees. Okay, so DAB and A2 are the same. Right, the first thing that they want us to do is calculate the size of D. All right, so they want us to calculate the size of D. So in other words, that is that angle over there. All right. Okay, so now it involves going back and thinking about all these angles on the inside of circles and trying to find something that we can use. All right, let's just go down here and let's see if you guys can spot it. Okay, D is equal to 52. So a lot of you have got that straight away. All right, so again, here is the angle at the center. O1 is the angle at the center. And the angle at the center is twice as large as the angle at the circumference. Okay, so there is your arrowhead. So quite right, matrix. In the first instance, A, D is equal to 52. Reason angle at center equals 2 times angle at circumference. Good, well done everybody, that's great. So we've done this one.
Remember to take screenshots.
Yeah, take screenshots. All right, now let's do the next one. So they want us to calculate the size of C3. Okay, so we know that D is equal to 52. Now they want C3, which is this angle over here. Now again, if I get rid of the purple and I use my highlighter, so let's make this yellow. All right, have a look here. There is C3. Look at this. Here is a bow tie. Okay, so straight away I can see that C3 over here is going to be equal to A2 over there. Remember, I already know how big A2, I know that it is 32 degrees. Okay, let's have a look. Okay, so C2, oh, you guys are already down there already. Yes, good, well done. Good. Okay, so you guys are being much faster than me. All right, let me speed up then. Okay, so C3 is going to be equal to 32 angles in the same segment. All right, question C, they want us to work out the size of angle A1. All right, so someone said something about that in the chat. Let's go back and have a look. Can we say, sorry, I'm just answering a question here. Can we say that C3 is equal to D? No, we cannot say that C3 is equal to D. C3 is equal to A2, D is equal to B. Okay, because of angles in the same segment. All right, if we knew that AD was parallel to CB, then we could say that D and C3 were equal because they'd be alternate angles, but we don't know that. Okay, so someone's got a hand up.
Yes, Romeo,
Yeah,
I did unmute you. There we go.
I wanted to say, it's actually Rona, but I wanted to say that for finding C2, could we just use the theorem of angles in a semicircle and then just equate C to 90, and then because we have C1 and C3, then we find C2.
Where do you have C1?
C1 is equals to A1 because of red eye.
Yes, absolutely. Okay, all right, that's fine. I agree with you. All right, so we know, let's just, sorry, I've rubbed off things here. So let's just put on the things that we know again. Okay, so we know that this is 104, don't we? So that means we can work out angle A1 and we can work out angle C1. And then you're saying, can we then work out C2? Yes, you're quite right, Rona. We can do it like that. That's not a problem. Okay, so I'm just going to write down what Rona is trying to say. All right, so what he's pointed out is that angle A1 is equal to angle C1 because OA and OC are radii, so they are angles opposite equal sides. Right, so in other words, they are equal to each other. So if I say in this situation, let A1 which is equal to C1 be equal to X, what I would have is 2 of X, so X plus 104 would be equal to 180. Okay, and that is because of the angles of a triangle, so angle, sum, and triangle. Now I've got this simple equation that I'm going to solve, so that means that 2x is going to be equal to 76, and that's why x is going to be equal to 38. All right, so therefore A1 is equal to 38. All right, good stuff. And then the last one, C2, again, what I'm going to do here is just rub all of that out. Here you can see angle in a semicircle. So there is your diameter. Okay. Here is the angle at the circle. So angle C is the angle at the circle. They want us to calculate C2, but we know what C1 is. Remember, C1 is the same as A1, it's 38. And we already know what C3 is. We know that it is 32. The first thing that we need to establish in question D, all right, is that angle C1 plus C2 plus C3 equals 90, angle in a semicircle. Okay, we know that C1 is 38. C2 is what we're solving for. We know that C3 is 32. Okay, so C2 is going to be equal to 90 minus 32 minus 38. So that means that C2 is really, really small, isn't it? It's going to be equal to 20 degrees, which I think somebody said. Okay, is that making sense to everybody? C2 is 20, yes it is. Okay, so Amahle, the videos are going to be posted on our website. All right, so you would go there and you would be able to rewatch it. Yes, Sihle,
Yeah.
quite right.
By tomorrow, the videos are clearly going to be there, guys. So you can rewatch it. Y'all did really well.
They did. All right, so just very quickly, I see Ethan had a question. I'm just going to go over that again quickly, Ethan, over here. All right. This line over here, Ethan, let me just make this a little bit smaller. This line over here is a radius. This line over here is a radius. That means that this triangle is an isosceles triangle because that side and that side are equal. That's why A1 and C1 are equal to one another, because they're angles opposite equal sides. So I can call both these angles X. So now when I add all the angles together, I get 180. So x plus 104 is 2x plus 104 equals 180 because of the angles of a triangle. And then I solve for A1. Okay, Ethan? There you go, Lisa Kanya. I've just explained it again. All right, now it's time for the poll, but what I wanted to do was leave this one with you guys. Actually, no, hang on a second. Where is it? It's similar. Okay, let's rather do this one over here, okay, for homework. All right, so you guys wanted extra practice with these sorts of things. I'm giving you question 6 to do. You are going to work out the size of angles A, B, C, and D. This one also involves tangents, which we unfortunately didn't get to. Okay, but take a screenshot and then I will show you the answers to that next time. Okay. Please do the poll.
For us, yes. But really appreciate it.
Okay. And then Rona, just do the poll and then we'll answer your question with pleasure.
So for those of you who thinks it's way too fast, please do let us know next on Thursday. Actually, you can just WhatsApp us send us a message saying that you want to go to the slightly slower class, which starts at 5 until 6. Okay, so even now you can clearly send us your name and we can recommend for you to go to the foundation class.
Oh, it's a pleasure, everybody. You're so kind to say thank you. We really do appreciate that, don't we, Yolanda?
Yeah,
So
we
all we
do.
want to do is make a difference to you guys. So if we're doing that, then that's great. Okay,
Yeah.
absolute pleasure.
And I love the fact that you can have this recording by tomorrow. So it's still fresh in your mind. Then you can definitely rewatch the videos. You guys
Thank you.
did really well.
Michaela. Thank you, Anya. Thank you, Jemima. No, Jemima, maybe. Sorry. No problem, Kutwano. It's a pleasure. Okay, cool, Darren. Okay, Nkunisa, I hope that made more sense now. Oh, buy a donkey. Lovely. Thank you, guys. You too have a wonderful evening, and we'll see you guys on Thursday. Yes, Rona. Pleasure, Ethan. Pleasure, Marsha. You too have a good evening. Rona, you're welcome to ask. Go for it, Katlejo, no problem. Okay, so Yolanda should unmute you. Yes, non-causal. Let's have a look if I've got any more questions.
As soon as I see your hand up, then I can unmute you because I'm
Okay.
looking at the chats for you,
These
but I
are
can't.
proving. So you can try question 6. You can also try this question here if you want to screenshot that.
Hello, ma'am.
Sorry, let me just make that a little bit smaller. Who's that? Is it you, Rona?
It's Katleho, ma'am.
Oh, Katlejo. Okay, sorry, Katlejo.
Ma'am, I only had one question. What are the most important key things to look at when you're answering these kind of questions?
Okay, so Katlejo, you really have to read the clues. So it was like I was saying which was it, this question over here. So when they use certain words, like the center of a circle, you've got to be able to relate that to a theorem that you know. Or when you read the words AB as a diameter, you've got to be able to relate that to a reason that you know. Or if we look down here at some of these other questions over here, we see it, we've got circle center O. So straight away, if we see the circle center O, we think about angle at center is twice angle at circumference. Or here where they say to us TAN is a tangent to the circle, we start thinking about tan chord theorem. So that is the most important thing.
Oh, okay. Thank you, ma'am. Thank you, ma'am.
Okay. All right.
I'll try
so
and
make
answer the questions and then come back on Thursday.
Perfect. That's perfect. Okay.